So welcome everyone. In the previous video, we talked about non-aqueous titration as well as the effects as well as the solvents which are used in non-aqueous titration. Okay, so in this video, we are going to talk about the effect which are being shown by the non-aqueous solvents. Okay, so effect of solvents. There are two types of effects. The first is leveling effect. The second is differentiating effect. Okay, so these both effects are important. Now let us begin with the leveling effect. So firstly I will read out the theory part and then I will try to explain it to you with an example. So a weak acid act as a strong acid in the presence of strong protophilic solvent, and weak base act as a strong base in the presence of strong protogenic solvent. This effect is known as leveling effect and the solvents are called leveling solvents. Okay, so firstly these terms protophilic and protogenic we have already discussed in the previous video. Okay, so protophilic means which have high affinity for protons and protogenic means which readily donate protons. Okay, so these are different types of solvents which are being used in our non-aqueous titrations. Okay, so now let us understand the leveling effect with an example. So for example, firstly we have taken water as a solvent. Okay, so we have taken a strong acid HCl and a weak acid which is acetic acid. Now what will happen that when the strong acid will react with water, it will dissociate into H positive ion. It will fully dissociate. Okay, and when a weak acid will react with this aqueous solvent which is water, okay, some part of the weak acid will remain undissociated, which means that this is not that much acidic. Okay, whenever we say the use the word acid, it means that the compound gives H positive ions. Okay, so in case of HCl, it has completely ionized into H positive ion, whereas in case of acetic acid some part of it is still as it is. Okay, which means this has not completely given its H positive ions, therefore it is a weak acid when it is being dissolved in water. Okay, so here our solvent was water. Now what will happen, now we are talking about non-aqueous titration, so we will take a non-aqueous solvent. Now in case of water, when we take ammonia as solvent, ammonia is a non-aqueous solvent. So what will happen that the strong acid, when it will react with ammonia, it will give ammonium ion. Okay, but the weak acid, what will happen that weak acid will fully dissociate. Okay, in the above example, in case of aqueous solvent some part was remaining undissociated, whereas in case of non-aqueous solvent it is fully dissociating, which means that now this weak acid has turned into a strong acid. Okay, so now I will explain again that what is happening, that this weak acid, which weak acid when it was made to react with water, it some part of it was remaining undissociated. Okay, but when we changed our solvent, instead of aqueous solvent, when we used non-aqueous solvent, now this weak acid is completely being ionized, therefore we can say that now this acid has become a strong acid. Okay, so by choosing a suitable solvent, we can change a weak acid to a strong acid or a weak base to a strong base. So this is what is happening in leveling effect. Okay, so what we are doing, we are using a suitable solvent in order to change our weak acid into strong acid. So I hope this thing is clear to you. uh, okay, ammonia is our protophilic solvent, and what in the definition we said that weak acids can act as strong acid in presence of strong protophilic solvent. Okay, so this we were having a weak acid, so we took a strong protophilic solvent ammonia, and it had high affinity for protons, so it gained these protons from this, and finally our acid was turned into a strong acid. So this was our leveling effect. Now let us begin to the next part, which is the differentiating effect. Okay, so the next part is the differentiating effect. Now uh, the effect of differentiating between the strength of acids is called as the differentiating effect. Now for example, in aqueous solutions, which means in water, the HCl, HBr, HI all are completely dissociated, that is all behave as strong acids. Okay, so when acid dissociates completely, previously also I explained, it means it is a strong acid, but if some part of it will remain undissociated, it means it is not a strong acid. So what is happening, that in aqueous solution all of these HCl, HBr, HI, they all completely dissociate, therefore we say that all of them are strong acids. Okay, but what happened that in solvents like glacial acetic acid, which is a non-aqueous solvent, extent of dissociation is this, which means that uh, hydrogen iodide dissociates greater than hydrogen bromide, which dissociates greater than hydrogen chloride. Okay, so which means that acetic acid exerts a differentiating effect on the acidic behavior of HI, HBr and HCl. Okay, I hope this thing is clear to you what is happening, that in aqueous solution what is happening, that all of these are equally dissociating, and that is why they all are strong acids. But in case of glacial acetic acid, the extent of dissociation changes, and the extent of dissociation decides which is strong acid and which is less strong acid. So non-aqueous solvent such as glacial acetic acid, the this HI is more acidic than HBr, which is more acidic than HCl. Okay, so what is acetic acid doing? Acetic acid exerts a differentiating effect on acidic behavior of HI, HBr and HCl. So acetic acid is an example uh, of the compound which exerts a differentiating effect. Okay, so differentiating solvents, so these are the solvents which have the ability to differentiate between strength of acids and bases. For example, acetic acid is a non-aqueous solvent which possesses differentiating property. It is having the ability to differentiate between the strengths of acids and bases. Okay, so I hope it is clear to you up to here. What we have done, we have talked about the different effects which are being shown by non-aqueous solvents. Okay, so I hope you liked the video. Please subscribe and thanks for watching.